Perimeter and area. What we're going to cover today, naming polygons, finding the perimeter. How do you find the perimeter of a polygon again? Add up all the sides. All right, so perimeter is distance around the outer edge. What if in real life, give me an example of when you need to find the perimeter of something.
Fence.
When you're putting up fence. All right, when you're putting up fence, is that the perimeter? Be able to find the area of polygons. Give me an example of when you need to find the area.
A room.
Like for what?
Carpet.
Carpet. All right, that's why when you see carpet ads on TV and stuff, they say
Per square foot.
per square foot. All right, per square foot. And actually now I think they say like 3 different ways. They say per square foot, per square inch, and per linear foot based on 12 feet or something like that, because it goes back to the idea again that the government thinks that all of you are stupid. You can't handle yourself, so they're saying the carpet companies are trying to rip you off, Bree. So we're going to make them say all of this because we can't trust you to understand it yourself, which is ridiculous, right? If somebody rips you off, then I'm sorry, but I think you deserve to get ripped off if somebody rips you off. That's my feeling. Be able to use the coordinate plane. We've been doing that whole year, so that shouldn't be anything new. Do we want to watch the videos again?
We watched
We
the first one. We didn't watch
Watch
the
one,
second one.
we didn't watch the second.
We didn't watch the second
We hadn't
one?
watched
Do we want to watch the first one again?
No.
Yes. No, let's watch the first one.
All right, watch first one again.
Bree, do me a favor, go flip the lights off, please.
I can tag to that.
I can tap to that.
No.
Did we talk about the video any?
Yeah.
A little bit.
So and I think we did this in this class, there's 4 things that this video says that actually mean something. Listen for them so you can answer my questions afterwards.
Okay. Teacher too. Drop that beat.
You got those 4 things memorized together? Definition of polygon, they gave it to you there, 4 things. What is it?
They don't
curve like a circle.
They don't curve like a circle.
No curves,
No open ends.
no open ends,
Lines don't
they don't
cross.
cross.
Alright, let's see. Here you memorize. Exactly. No. Ooh.
Okay.
Alright, the guy that sings this, there's one word that he uses through here all the time, and he's using it wrong. I'm going to give 5 points to everybody who can write that word on this piece of scrap paper and turn it into me after the... One word is all it is.
Polygon.
Here you go.
I bet he's using polygon wrong. Can I still write it?
Oh. Was it anybody? Okay.
He's using the air wrong.
3, 4, 5. Watch out.
Alright, you got about 10 seconds.
I bet I know it.
Put your name on your scrap paper, lay it right there on that desk where Curtis was sitting at before.
Confidence.
I'm gonna go. You live there, they want it.
Throw mine away. Wait, I forgot to put my name on mine.
What was it? What's the word?
Sides.
Sides, I heard. Any other answers?
Polygon.
Lines.
Mine's not neck.
Lines could connect,
Well,
but
it's-
are the sides of a polygon a line?
No.
What are they?
Segments.
Segments. So lines was the correct
Well, let me
answer.
rewrite that.
Lines.
Dang.
So they were saying when lines connect, well, lines can cross each other, but are the sides of the polygon actually lines? No, they're always segments. Something got stuck on here. Looking at this, is this a polygon? The
No.
first one.
Yes.
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 What's your yes?
Why is it yes?
Because there's
There's four sides,
two-dimensional.
Two-dimensional,
No open edges.
no open,
no open ends,
and no curves. Was the fourth one?
Crosses.
they don't connect.
They don't cross each other. Polygon?
Nope.
Nope.
Because
Yes.
they cross, right?
Next one is a yes.
Yes?
No.
No, how come?
They
It's
curve.
got curves. Right.
Ooh.
Write this down, polygons. I must have put some, just write polygon first, we'll give that definition. Now, I don't want to, I'm probably never gonna ask you on a definitions test to give me the definition of a polygon, because if you look in the back of the book in the glossary, it probably gives some long drawn out definition that's about a paragraph long, explain it. The thing I want you to know about polygons is those four things. What's one of them?
They don't
Two-dimensional.
They don't
Two-dimensional,
curve.
slow down. Two-dimensional,
They don't curve.
no curves,
They don't cross.
no crosses,
No open ends.
no open ends. Oops, can't spell. You can remember that, that's good enough to remember what a polygon is. Next thing, concave. Anybody remember when you talked about polygons in the past, you probably talked about concave and what other kind of polygons?
Convex.
Convex, good. Anybody remember what's a concave polygon?
Yeah, we didn't know last year.
Didn't? Should have probably, well,
Does that like go in?
it goes in, right? Again, the definition on this, I'm probably never gonna ask you to write the definition for a concave polygon. I do sort of want you to write this down. We won't use concave polygons very often.
I forgot the notes.
Keep writing. We won't use concave polygons very often. Probably the only time we'll use concave polygons throughout the year is when they ask you, is this polygon concave or convex? All right, we don't usually use concave polygons because all the geometrical rules that we're going to do for the other polygons don't work for them. So a concave polygon. What I actually want you to remember about it is interior angle, at least one, it could have 2, 3, 4, 5. An interior angle, and we haven't even talked about angles yet, so an interior angle is more than 180 degrees. Now what that means, if I'm standing here and I turn and look this way, how many degrees did I turn? 180. All right? So if that angle's more than 180, then I'd have to do what? Maybe turn that way. All right? So draw this picture right here, that's a concave polygon, or that's an example of a concave polygon. And the reason, if we look at the angles inside this polygon, we have an angle right here, but it looks like it's a right angle, so it's okay. But this interior angle, that interior angle right there, see how it's spread more than 180 degrees? That makes it the polygon concave. What do you think the next word up here is? Convex. Put a star or asterisk or something beside this one. This is the one All the polygons that we deal with will be convex. Instead of interior angle more than 180 degrees, convex polygon, no angle more than 180 degrees. No angle more than 180 degrees. That's a convex polygon. What you normally think of if I ask you to draw some polygon would probably be convex. Now I know my son a couple years ago came home and he had to draw his name in polygons. You know, some math teachers do stuff like that.
How would that work?
We're not doing that. So his name started with a T, so what do you have to do?
How would mine work?
Is that a polygon?
Yeah.
Yeah.
How would mine work?
But is it concave or convex? Concave, right? Because does it have angles more than 180 degrees? Yeah, this angle right here is more than 180. Curtis asking how he could draw his name. Couldn't we do that, Curtis? The last one, this term down here at the bottom, the next term, you will need to know this. So write that down, then we're going to put the definition. A regular polygon. A regular polygon. Regular polygon's very, very important. Alright? What a regular polygon is. Anybody have a guess as to what a regular polygon is?
Regular polygon.
Square is a kind of regular polygon. What would make it regular? Even sides.
4.
And
Actually, 2-dimensional.
what other parts does a polygon have? It's got sides and it's got angles. Even sides and even angles. Right? So in a regular polygon is a polygon with all sides. What's this symbol mean? Congruent, good. And all angles congruent. Got to know that. So I know Caleb's writing this down right now. Good. Yeah, that way you get to start understanding and using it. By the end of the year, Curtis, I won't write that word out. All these words, I probably will write symbols for them all to make it shorter. And so you got to know all the symbols. So regular polygon, polygon with all the sides equal or congruent and all the angles equal or congruent. So you guys named squares, rectangles. I heard people hollering that out. One of those isn't a regular polygon. Rectangles aren't regular polygons, are they? Not all the sides are equal. Square is. Maybe an octagon. Does an octagon have to be?
No.
Because could all the sides be different in an octagon?
Yeah.
Yeah. All right. How about this? Anybody remember what name that shape right there would be given?
Hexagon.
Hexagon. Is that hexagon regular?
Yeah.
Does it look like it?
Yeah.
It looks like all these angles are the same. Looks like all the sides are the same. Now, are we just going to assume that when we're doing these problems? Are we just going to assume that all those are the same?
Mm-hmm.
No, they're going to tell us something, and they'll be tick marked or something like that, like I just put up there to tell us, hey, all those sides are the same and all the angles, and we'll talk
Why does
about
the
angles
music
later.
play every time you hit the board?
Because I shut down that little thing. Right. Okay. Number of sides. Draw this. try to fill this in. And we'll fill it in together here in a second.
Do we write this on the note?
Yep, in your notes.
Alright.
So, number of sides, 3, 4, 5. How come I skipped 1 and 2? What's the polygon that's got one side? There isn't any. What's the polygon that's got two sides? Nothing.
I don't know three.
You don't
Oh, yeah, I
know?
do. I'm dumb. I don't know why I said that.
Tell you why you said it.
Cause I'm dumb.
No, because you like to hear your mouth before you use
'Cause I
your
think.
brain. I think that's just a common problem that you have, Curtis. You don't always use your brain before you use your voice. So Caleb, on your answer that you gave me, you said that they were wrong when they said heptagon.
Yeah, I ain't never heard of the heptagon.
What do you call it?
I don't know.
Because
I've heard of the
there
hectagon, but-
there are two different names for that certain shape. So when you get here to this one, there's actually two different things that you could put down there. All right, three-sided
Triangle.
triangle.
I got it.
So triangle, three-sided, four-sided.
Square.
Be careful.
And right here.
I hope you didn't write down square, because if you did, you need to mark it out. What is it? Quadrilateral. Now, there's another name that's been out, and it's, I know about 4 years ago, my son was in like 3rd grade, and his book didn't call it a quadrilateral, it called it a quadrangle. What's quadrilateral mean?
Four.
Four sides. What's quadrangle mean? Four angles. So either name is appropriate. Five-sided,
Pentagon.
pentagon. Six-sided, we just did one. You guys told me what it was on the last slide. Hexagon, thank you.
Oh.
It's a hexagon. Seven-sided,
Octagon.
Yeah.
Same.
Yeah.
now, the other name that a lot of books are using now instead of heptagon, septagon. Why do you think they're switching it to septagon?
Seven.
To go with 7 to make it easier for you to remember.
Hey, they actually did something different.
Alright? Heptagon, septagon. How come nobody remembers this, but you remember most of the others?
I don't know.
You guys get mixed up.
Cause you don't usually use
We don't
that.
use 7-sided, right? Very good,
You,
Curtis. We use 3-sided shapes a lot, 4-sided shapes a lot, 5-sided, 6-sided. 7 we usually don't use. My thing clicked. What's 8-sided?
Octagon.
Octagon. We use that quite a bit. Where do you see that the most often? Stop
UFC.
sign. Stop sign. 9-sided. No, another one that maybe if you were watching that video a little closer, you'd remember it, right?
Nonagon.
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 Nonagon. How come you don't remember 9-sided?
You don't ever use it.
We don't never use it. Now I'm not gonna take this off. What's a 10-sided?
Decagon. Decagon.
Decagon. Oh, I thought it came up. How come it came up last time? Decagon. Use your brain a little bit here.
Decade.
A decade goes with 10, right? And that's where all these come from. So, a triangle, what's tri mean? 3. Quad, 5, 6, 7, octa, 8, non, 9, 10. All
I
right?
just remember 8 months.
Now, the bad thing with that, 8 months, October's not the 8th month.
Yeah.
Now, don't see.
Oh, that's my bad. Yeah.
Don't laugh at Evan because Evan's right. Why is it called October? Because it used to be the 8th month before some scientists got smart and said, because then they only had 10 months. And how long does it take the Earth to travel around the sun? 12 months. All right? So somebody figured out that, hey, 10 months isn't enough because one year, October was really, really cold. The next year it was warm and it fluctuated. And then that's sort of stupid, isn't it? You expect in December it's going to be cold in
Well, not
Ohio.
necessarily in
Not
Ohio.
that it switches every few years. All right? So October used to be the 8th month, but now it's the 10th month because we added into. Use all that, those prefixes and stuff. Can anybody figure out what a 12-sided figure is called? What would a 12-sided figure be called? Use the last one that we just put up here. Deca. What's deca mean?
10.
10.
It's,
How many more than 10 is it? 2 more, right?
What's
What's the prefix for 2?
what? Tekadon.
What's the prefix for 2?
Swekagon.
There's a few of them.
Tugagon.
Deuce.
Not deuce, actually.
Tugagon.
Doe, right?
Doe.
So guess what the name for a 12-sided figure is?
Dosagon.
Put the two of them together. Doe,
Cagon.
dodecagon. Dodecagon.
Yes.
All it does is put them together. Dodecagon. Getting that, Lexi?
Yeah, she got it.
Are you lying to me?
she got it. You're not her.
Those are the only ones that we actually give proper names to. What if we wanted to do an 11-sided figure? Make up a name for me. Use your brain a little bit.
I hope they do it after we leave. ice cream.
Uno decagon.
Yeah.
Decagon. Something like that maybe. Right? That'd be for 11.
Decagon.
Yeah.
Now, we don't usually have names for 11, 13, 15, any of the others, but could we make up names for all the rest of them?
Yeah.
Yeah, we could, but it's not something you want to memorize. How about something that's got N sides? Listen closely on this because this confuses everybody. What's that mean if it's got N sides? Do we know the number of sides? No. So what we do on that is we just call it an N-gon. Now, a lot of the problems in the book will be that way. So if I gave you a shape and I told you it had 27 sides,
Ingon.
you're going to call it a 27 gon. You just add gon to the end of it. All right? If it had 52 sides, what would you call it? 52 gon. All right? Because we don't want to try to memorize names for every possible shape there is in the world. There's an infinite number of them, and we could never do it. Next one, write this down. Perimeter and area of a triangle. Perimeter and area of a triangle. Draw that picture. What's the perimeter dealing with again?
No.
Adding up all the sides. Distance around the outside of it. What's area dealing with?
Inside.
How much will fit inside of it?
Yeah.
Down at the bottom, I'm not sure why I put perimeter first and then area on the formulas, and then I switched area and perimeter on the bottom. I'm not sure what caused that. I don't remember switching them like that. Just make sure you keep them straight with each other. On this, listen closely. Perimeter, P stands for perimeter. We're also going to do a lot with probability this year, so don't get perimeter and probability. When you're doing probability, it's going to look like this, and it'll have like P parentheses, and then whatever outcome you want to occur. So maybe we're flipping a coin, and we want to flip a heads. So it'll say P, what's the probability that you get a heads? Don't get those two P's confused, all right? Probability, perimeter, two different things. Find the perimeter of a triangle, all we do is what? Add up all the sides. How many sides does it have?
Three.
Three. So you add up those three answers, or those three numbers. Just add them together.
Is geometry easier than algebra one?
I don't know. Find out as we go.
It's so far easier, but I
Good.
don't know about that.
Area. When you're finding the area, what you're actually finding when you're finding the area is if I start to try to fill this shape with these little squares, how many of those little squares would fit inside there? Now, can I actually go through there and find the little squares? Probably not, because when I get over here to the corner, there's going to be a whole square there, and then you're going to have to try to go like, and you might remember this from like 4th grade where they give you the shape on a coordinate system and you had to count the little blocks, and then you got a half a block here and a half a block there, and you had to try to estimate it out. We don't want to do that. The formula is this: 1/2 times base times height. Where's the, this is your base. You might want to write that in right there. Base. This is your height. Where's the base of the triangle located? The bottom. Now that's not always true. So you got to be careful of that, and that's why I brought it up. Because just because it's the bottom of a shape, does that mean it's the base? No. What if I drew this triangle? Same triangle, but I drew this. Is this the base? No, the base now would be there, right? So you don't think base always means bottom. That's for anything. If I have, trying to see here what else I have. I don't have any cylinders laying around here anywhere. I have this sort of a cylinder. This is a cylinder, right? If I lay that cylinder there, does that mean the side that's touching the desk is the base? No, the base is the actual circle here on the end. So don't think of base as always being the bottom. The way you can find the base and the height in a triangle is always going to be given going from the top down to the bottom, and it'll be given with a little right angle symbol. Does everybody know that that means a right angle? That little square in the corner means a right angle. Everybody knows that, I hope.
Yeah.
Right, so that means a right angle. When you're looking for the height, that's what you're going to look for. Where's that right angle? Notice that this right angle sets on this side. Guess what that tells you about that side? It's the base. Okay? Sometimes you'll see triangles maybe that look like this. And then they'll give you something outside here. This is your height. That out there is your height in that case. So when they extend one of the sides out and they put it on the outside, it's because they couldn't draw the height inside. All it is you're standing, it's like you're standing up here at the top of the triangle, and you have a piece of string, and you drop it straight down. What kind of angle is that string going to form with the ground when you drop it straight down? 90 degrees, right angle. That's the height of the triangle. However it's given, whether it's given inside like on this one, outside like on that one. Another height of this triangle could have been, we could have drawn it in here and made that the height, and then that would have switched it. Instead of this being the base, then that would have had to been the base. So the base is where that right angle, which side that right angle sets on. In this formula, 1/2 times base times height, Curtis might want to write this down.
I've got it.
Instead of writing down what I have right there, it's base times height, and it might be easier to do it this way because you don't like the fractions, you don't like the 1/2. Base times height, and then you take that answer and you do what to it? Divide it by 2. So if you write down that formula, maybe that formula is a little easier for you. They both mean the same thing. It's both the exact same formula, just written 2 different ways. You got to remember this, your units. The units that I have down here at the bottom. If you're dealing with perimeter, and I want to walk around the perimeter of the room, and I measure it as I'm walking around it, I'm just walking in feet or meters or whatever. No extra part to it. You're just counting the feet or the meters. But if you're doing area, then it's square units. So for area, you might want to write that down, square units. Always square units for area. And the reason it's square units is when we're finding area, what are we trying to figure out? How many little blocks or squares will fit in there. That's why it's square units. Square units for that, regular units for perimeter, feet, inches, meters, centimeters, whatever it happens to be. Caleb, that makes sense? Got to make sure you put your units on everything. If you don't put your units on something, I'm going to mark it wrong. Got to put your units. All right, write this down for a square. Draw that picture. As you're drawing this and writing this down, what's these little corner things tell us? Right angles. What's these little tick marks tell us? What about the sides? They're all equal. Remember those little tick marks when you put the same, when things are marked the same way, then that tells us that they're equal to each other. They're congruent to each other. So that tells us in this case that all four sides are congruent. That's what makes a square. What do we know about a square again? What's another name it could be given? It's a quadrilateral. Now not only is it a quadrilateral, but what other kind of quadrilateral could you call it? Starts with an R. Regular. A square is a regular quadrilateral. So if I said a regular quadrilateral, and this is the kind of thing that they would do on the end of the year test in geometry. They wouldn't tell you it's a square, they'd say, this shape is a regular quadrilateral. But you should know that that means it's a square. That's the only shape that can be a regular quadrilateral. In a square, how do you find the perimeter of this square? Add up the four sides. What's an easier way maybe? 4 times whatever one of the length of the sides is, because they're all the same, right? So instead of saying, if it was 10, 10, 10, and 10, instead of saying 10 plus 10 plus 10 plus 10, it's probably easier just to say 4 times 10 in the perimeter. Right. Probably done a lot of it before this. The area. Area of a square is just the length of one of the sides squared. You might want to write this down. Area equals, if that S squared confuses you, maybe Caleb gets confused by that, then it just means S times S. So if you write that down, that might make it a little easier on you. What would the area of this square be?
100.
100. 10 times 10. Brielle, that makes sense? Easy stuff, right? Now let's get to the hard stuff. Just kidding. Rectangle. Draw this and write this down. Chloe, you still with us?
Everybody's gone out of here. So quiet.
Don't make me get my phone at you guys and start taking pictures and emailing them home.
Really?
Yeah, I've done that before. Yeah,
Your class is probably the only class I had was selected this year yet,
that's good.
which is really smart.
What's these tick marks on here tell us about these two sides?
They're about the same.
They're the same. How about these other two sides? They're congruent. Does that mean all 4 of them are the same?
No.
Because they're marked different, all right? So you gotta start understanding those tick marks. What's these little symbols in the corners tell us?
Right angles.
Right angles. What's the L stand for?
Length.
Length. So you might want to write that down. Length. L stands for length. Notice it's sort of a cursive L. How come I didn't just make a regular lowercase L?
1.
Because that's a lowercase L. It looks like a 1, and that would confuse everybody. So that's why we make it cursive.
I thought that was the E.
Yeah, it does sort of like an E. I tried to find a good one on the computer, but that was the best I could do. What's the W stand for?
With,
Width. To find the perimeter, do we ever really need to use this formula right here? No, probably what's an easier way? Just add all the sides, right? That's what I would do to find the perimeter of a rectangle. I would probably never ever use that formula. I'd just say, okay, this side plus that, plus that, plus that, and get the answer. Right now, with what we know here, somebody tell me how long is this side? That side over there is W, what's this side?
go ahead.
How long is this side?
L.
L. Alright, because we know that they're the same, right? We don't know the numbers, but we do know letters for them. What's this down here tell us to do?
Times width.
Length times width. Remember for this one, remember again for area, it's always square units. Square units with area, regular units for perimeter. Alright, write these down again, and I know Curtis is gonna say, but we already wrote those. Is that gonna kill you, Caleb, to write them down again? No, probably be helpful, right? Because as you write things, remember when you're back in 3rd grade and you had spelling tests every week? What did your teacher make you do every week? Write the words like 10 times, or 5 times, or 15 times, or something, right?
I remember I had a spelling test, but it's spelled supercalifragilistic.
Using the midpoint formula, we did this back at start of class. Remember, you just add the x coordinates together. You're given 2 points. You add the x's from those 2 points together, divide by 2. You add the y's together, divide by 2. And it gives you 2 separate answers. It gives you an x coordinate and a y coordinate. Do not make midpoint harder than it is. That should be an easy formula. Distance formula, this is the one that we're going to use more in this section. We're not really going to use, I don't think we use midpoint a whole lot, but I put them both up here. Distance formula tells you the distance between one point and another. You plug into that formula, what's the thing that you got to make sure you have so that you can do the distance formula? Calculator. You plug in the 2 x's, here and here. Plug in the 2 y's, then start to do the math. Don't make distance formula harder than it is either. Every time I see that, hey, I got 2 points and I want to find the distance between those 2 points, again, I just write the skeleton. I do this every single time. That's the skeleton of that formula. And then I know just put the 2 numbers in here in the first set of parentheses, put the other 2 numbers in there in the second set of parentheses. Then start to do the math, one step at a time. How many answers should you have for the midpoint formula? Just said 2. An x coordinate and a y coordinate. How many answers should you have for the distance formula? 1. A length. 6.7 centimeters, whatever it happens to be. And we only use these when you're given 2 points. So when it comes time for the chapter 1 test, and problem number 7 looks like this. What's a good guess as to what you're going to do on that? Or use on that? Midpoint or distance? Alright? Maybe both. If you see something that looks like this in a problem, then it's a good bet. You're either going to use midpoint formula or distance formula, maybe both.
You have to memorize those for the test.
Right. Even though, after a while, if you just look at them, are they really that hard to memorize?
No.
Right. Get out a clean sheet of paper, write this down. Curtis, you want to stop there? We can stop there. Want me to stop
So what?
teaching? Because this is part of your homework and I was going to help you through it and do it stuff, but you don't want me to. You said, oh my gosh, like it was something bad that we were getting ready to do. Clean sheet of paper, open up your books to page 34. Page 34. Four.
So if we don't finish this in class, this will work.
Well, that's part of it. There's more added onto it. So you're gonna have homework regardless. It just depends on how much, by how much we get done. Complete the sentence. The perimeter of a square with side length S is P equals what? 4S. Write that in there. Stupid thing. Didn't switch the pen. 4S. P equals 4S. What formulas can you use to find the area of a triangle in a coordinate plane? What formulas? We want to talk about two.
Area, distance.
Distance formula. Distance formula. Because you're going to have to find the lengths, right? Distance formula. This is an S, not a 5. So this is 4S. 4 times the length of the side. Next one, number 3. Somebody help me out with number 3. I don't know what it says.
Is it convex or concave?
That's all they want to know, convex or concave?
Yeah.
Nothing else? Read the directions carefully. That's it?
Yeah.
So convex or concave?
Convex. Concave.
Concave. How can you remember that maybe?
Because it has a big one,
Concave.
big angle.
It sort of caves in, doesn't it? If it's knocked in, concave. Go ahead, tell me.
The directions also say classify the polygon by the number of sides.
Oh my goodness, so you guys lied to me. Evan, I told you to read it and make sure.
I did.
So it's concave, and we got to give it a name. Quadrilateral. Yeah, you read that just like you read that on that quiz where you had to find the length too. Evan's used to this easy algebra crap where they give you a problem and it's just got one answer. A lot of these are going to have 2, 3 answers. You're going to fix that, right? You're going to fix that in your head, right? Number 4. Convex. Triangle. Hopefully you guys are listening, because if you can't read my cursive, then you're just sort of out of luck. So listen also. Number 5. Convex. What is it, Austin? A pentagon. We don't talk about pentagrams in here.
What is a pentagram?
It's still the same thing, it's just got triangles on top.
Devil worshiping thing.
Really?
Yeah, I have to wonder about Austin now.
Ah.
About
Is that convex?
pentagrams. Convex. Oh, sorry, I spelled it wrong, didn't I? Austin got me all shook up. Talking about pentagrams and killing goats and stuff.
Killing goats. Is that what they do?
Next one.
What are they? Hate
Concave.
Concave. What kind of shape is it? Hexagon? Heptagon?
Hexagon.
Hex?
It's a
How can you tell?
Because it's got 6 sides.
6 sides.
1, 2, 3, 4, 5, 6. Just count. So hexagon. Next one is it a different group or same kind?
Number 7.
Different. Number 7. What do they ask us to do on number 7?
Find the perimeter polygon.
Find the perimeter of the polygon. So we need to draw this. So I'm gonna, if you need graph paper, there's graph paper up here, grab some before you leave. Might grab 3 or 4 sheets and then just keep some with you so that you don't have to grab it every day when we're gonna do this. I'm gonna graph this real quick. Tell me how to graph point G.
2 over 2
Say it again.
up 4. 2 right.
Right 2,
Up 4.
up 4. That's point G. H,
Right down, down to.
right 2, down 3, good. J,
Left 2.
Left 2 down 3. Left 2 up 4. Okay. We want to find the perimeter of this red shape that I've drawn here. Do we have to use the distance formula to find the lengths of those sides?
No.
No, because what's special about them?
Straight.
They're all sides are straight.
Vertical.
Vertical or horizontal, right? Vertical or horizontal. And I'll probably get Evan all year long on that saying like lines are straight. What do we know about all lines? They're all straight. No reason to say straight line or something like that because we know they're straight. How long is segment KG?
5.
4, 5,
That's 4.
1, 2, 3, 4. Remember, count spaces, not lines. How long is JH? 4.
I'm doing everyone, sorry.
Count this.
1, 2, 3, 4, 5, 6, 7.
How about this one?
7.
1, 2, 3, 4, 5, 6.
What do we do with all those?
Now we go 22.
4 plus 4 plus 7 plus 7.
That's 20.
22.
22.
Did they give us units? No. So if they didn't give you units, write this. Units. So that's number 7. Next one, number 9. Everybody have that much so I can erase that? Number 9. I'm going to draw in my X and Y axes again. When you, that's horrible. When you grab graph paper over here, I actually have this kind of graph paper. It's got like 12 of them, 6 on each side. So that you can do number 7 on this one, number 9 on this one, so on and so on. Instead of grabbing one big piece of graph paper and trying to fit them all in there, that might make it a little easier sometimes, depends on the kind of problems you're doing. If I graph this real quick, -2, 4. If I graph something wrong, somebody please tell me. That's U. V is 3, 4. 1, 2, 3. 1, 2, 3, 4. That's V. And 3, -4. 1, 2, 3. 1, 2, 3, 4. That's W. So we have that shape. Tell me what kind of shape that is. Triangle. Is it any special kind of triangle?
Right triangle.
It's a right triangle. That's a right angle right there, isn't it? If that's a right angle, then this side is the what? That's the base. And this side over here is actually the height. So we don't actually have to go through and try to find the height inside the triangle because that's going to be the height. Can I find the length of that base? 1, 2, 3, 4, 5. Can I find the length of the height over here? 1. Now the bad thing is, can I find this length? No. What do I have to use to find that length? Now I have to use the distance formula. This goes with this problem. That's horrible that you actually have to do some math. So on this, I'm using U and W. So I want that coordinate, or that ordered pair and that ordered pair. What's my X coordinates here? Caleb, what's my X coordinates for U and W?
-2 and 3.
So I put in -2, -3. Somebody have a calculator ready to help me. 3, what's my Y coordinates for U and W? 4 and -4.
240.
What's -2 minus 3?
-5.
-5. I'm going to square that here in a second. What's 4 plus 4?
8.
Square that. What is -5 squared?
25.
Is it -25?
No.
25, right? What's 8 squared?
Plus 64.
64. What's 25 plus 64?
89.
89. Curtis, what do you do if you don't know? Don't say it. Square root of 89, is that one of our perfect square numbers? No, somebody grab a calculator and help me out with square root of 89. 9.3, 9.4. Lots of guesses. 9.4. Austin, yours wasn't a guess, you'd already done it?
Yeah.
So this side over here is 9.4. How are we going to find the perimeter of that shape then? Add them all up. So perimeter equals, what 3 are we adding up here? 5 plus 8 plus 9.4. It's 5 plus 8. 13 plus 9.4.
22.4.
22.4, and again, it's just units, because they didn't tell us any units. You could have. And it would have been, it gives you the same answer, right? And that's all the distance formula is. The distance formula is derived from Pythagorean theorem. How could we find the perimeter of this one? Probably not gonna have time, we're gonna run out of time. What's the length of that?
2.
2. What are we gonna have to do with all the other sides? Do the distance formula. You have to find the coordinates. Somebody help me out, what's the coordinates of P down here?
-1, -2.
1, 2,
-1 there.
oh, okay, yeah, you're right, I'm sorry, I'm looking at the wrong thing. -1, -2, I was looking at that being the center. So you find all those coordinates, then you find each one. You'd have to do the distance formula 3 times and add them all up there. Get away from that, get away from that, get away from that. Area, same idea. All right, write this down, that's your assignment. We're gonna skip the exit question again. Make sure you write this down, that's your assignment.